Good morning, students. In a previous class, that is class 1 of the chapter group 15 elements or nitrogen family, I completed the introduction, electronic configuration, general trends in physical property, general trends in chemical property, and the abnormal behavior of nitrogen. Today, that is the class 2 of the chapter group 15 element or nitrogen family. I will try to complete the method of preparation, property, uses of dinitrogen, method of preparation, property, uses of ammonia, allotropic form of allotropic form of phosphorus, and the oxoacid of nitrogen. Let us discuss one by one. First one is the method of preparation of dinitrogen. First one, methods of preparation of dinitrogen, that is N2. 2 to 3 methods are there, important methods for the preparation of dinitrogen. Let us discuss one by one. First one, the laboratory method. Generally, 3 different ways in the laboratory dinitrogen is prepared. Bit 1, by the thermal decomposition of ammonium nitrate. First one is by the thermal decomposition of ammonium nitrate in the laboratory. When you select ammonium nitrate, that is NH4NO2, that means NH4Cl plus NaNO2 give rise to NH4NO2 plus NaCl. Next, NH4NO2 upon heating N2 plus H2. Mark that. In the laboratory, while taking the equimolar solution of ammonium chloride and sodium nitrite, what is the form? Ammonium nitrite and sodium chloride, and by heating the ammonium nitride, we found the dinitrogen. In this method, along with the dinitrogen, little amount of nitric oxide and nitric acid is formed as a byproduct. Repeat again. Along with the preparation of dinitrogen, little amount of NO and HNO3 is formed. So in order to remove that impurity, the gas is passed through, the resulting formation of product is passed through aqueous solution of sulfuric acid containing potassium dichromate. Finally, the gas is collected by the downward displacement of water. It is one of the method of preparation of dinitrogen. In laboratory, second method also there, by the thermal decomposition by heating ammonium dichromate. Mark that. Second method. By heating ammonium dichromate. Formula NH4 whole twice Cr2O7. Mark that. When ammonium dichromate strongly heated, resulting the formation of N2 plus H2O plus chromic acid Cr2O3. Mark that. It is the second method by heating the ammonium dichromate. When ammonium dichromate, its name is ammonium dichromate. When ammonium dichromate strongly heated, result in the formation of dinitrogen. Move to the third one. That is by heating, by thermal decomposition of metal nitride. Third method. Third one. By thermal decomposition of metal azide. Suitable example, sodium azide and barium azide. Mark that. Resulting the formation of dinitrogen. Barium plus it is known as sodium azide. It is known as barium azide. That means by the thermal decomposition of metal azide, when sodium azide and barium azide strongly heated, resulting the formation of dinitrogen. It is all about the method of preparation of dinitrogen. Next, switch over to the properties of dinitrogen. Next one is chemical properties of dinitrogen. Point 1. Action with metals. When dinitrogen treated with metal, resulting the formation of corresponding metal nitride. For example, lithium plus dinitrogen give rise to lithium nitride. Aluminium plus nitrogen give rise to aluminium nitride. Calcium plus nitrogen give rise to calcium nitride. Magnesium plus nitrogen give rise to magnesium nitride. Mark that. Mark that. Metals like lithium, aluminium, calcium, magnesium, when treated with dinitrogen, resulting the formation of corresponding metal nitride. Next chemical property, action with non-metals. Next is second one, action with non-metals. When dinitrogen combines with dihydrogen, when dinitrogen combines with dihydrogen, resulting the formation of ammonia, the favorable condition, that is low temperature, that is 720 Kelvin, high atmospheric pressure, that is 200 atmospheric pressure, and the finely divided powdered iron act as a catalyst supported over molybdenum. Mark the equation. N2 plus 3H2 give rise to 2NH3. As del H is negative, favorable conditions for maximum yield of ammonia are low temperature, that is optimum temperature, that is 720 Kelvin, high pressure, that is optimum pressure, that is 200 atm, that is finely divided iron, finely divided means powdered iron acts as catalyst supported over molybdenum as promoter. These are the favorable conditions for maximum yield of ammonia by Haber's process. Another example also, when dinitrogen combines with dioxygen, resulting the formation of nitric oxide. Mark the equation. Next is dinitrogen combines with dioxygen, resulting the formation of nitric oxide. These are some examples of that is action with nonmetals. Next chemical property, that is action with alumina in presence of coke. Next, third chemical property, action with alumina Al2O3 in presence of coke means carbon. Mark that. Al2O3 plus C plus N2 give rise to aluminum nitride ALN and CO. Its name is aluminum nitride. It is alumina. That means when alumina treated with dinitrogen in presence of coke, what is it formed? That means aluminum nitride is formed. Move to next chemical property, that is action with calcium carbide. Next chemical property, action with calcium carbide. Next chemical property, action with calcium carbide, formula CaC2. Mark that. CaC2 combines with the dinitrogen give rise to CaCN2 plus C. This mixture is known as calcium cyanamide. Calcium cyanamide. Mark that. It is calcium carbide. Mark that. When calcium dinitrogen combines with calcium carbide, resulting the formation of calcium cyanamide. And the well-known mixture, the mixture of calcium cyanide with coke, this mixture is known as nitrogen, used as a potent fertilizer. Mark that. The mixture of calcium cyanamide with carbon coke is known as nitrogen, used as an important fertilizer. These are the method of preparation of dinitrogen. The method of preparation and chemical property of dinitrogen. Next we go to the uses of dinitrogen. Next is uses of dinitrogen. So many uses of dinitrogen are there. That is, liquid nitrogen is used as a good refrigerant. Mark that. Point 1. Liquid nitrogen is used as good refrigerant. Next, it is used in the manufacture of ammonia, nitric acid, etc. Next, nitrogen gas is used in electric bulb. Next, it is used for the manufacture of fertilizer. These are some uses of dinitrogen. Next, switch over to the method of preparation of ammonia. Next, methods of preparation of ammonia. First one, laboratory method. Ammonia is prepared in the laboratory by reacting with mixture of ammonium chloride with slackline. Mark the equation. Ammonium chloride with slackline calcium hydroxide, resulting the formation of calcium chloride, plus water plus ammonia. This ammonia gas is dried. By passing through quick line. Very, very important question is there. That is, though concentrated sulfuric acid, anhydrous calcium chloride, phosphorus pentoxide are well-known drying agent, yet these are not used for drying ammonia because they react with it. It is a laboratory method of preparation of ammonia. Move to the second method. By heating Second method is there by heating metal nitride. That is by the action of a metal nitride with water. Mark that, second method. By reacting with metal nitride with water. By heating metal nitride with water. Mark that equation. Aluminium nitride plus water give rise to aluminium hydroxide plus ammonia. Its name is aluminum hydroxide, it is aluminum nitride. That means when metal nitride reacts with water, resulting in the formation of ammonia. Move to the third method, that is method of preparation of ammonia by Haber's process. Move to third one, that is by Haber's process. It is the industrial method of preparation of ammonia. When dinitrogen combines with a dihydrogen, resulting in the formation of ammonia. Mark the equation. N2 gas plus 3H2 gas give rise to 2NH3 gas. Del H is equal to negative. In order to get the maximum amount of product by applying Lee-Chatter principle, the favorable condition, point 1, as it is exothermic, that is low temperature, that is optimum temperature, that is 720 Kelvin. It is 1 volume, it is 3 volume, 4 volume, it is 2 volume. That means high pressure, that is optimum pressure is equivalent to 200 atm. Next, finely divided iron as catalyst, supported over molybdenum as promoter. And pure nitrogen and hydrogen gas. These are the favorable conditions for maximum yield of ammonia by Haber's process. It is all about the method of preparation. Next, switch over to the properties of ammonia. Next is the properties of ammonia. Chemical properties of ammonia. Point 1, basic nature. Aqueous solution of ammonia is a basic in nature due to the release of OH minus ion. So it turns red litmus to blue. As it is basic, it combines with acid, resulting in the formation of salt. Mark that. NH3 plus HCl give rise to NH4Cl, ammonium chloride. Ammonia, NH3 plus H2SO4 give rise to ammonium sulfate. As it is a basic nature aqueous solution, NH3 plus H2O give rise to NH4OH. When ammonium hydroxide NH4OH ionizes, ionizes, resulting in the formation of giving the hydroxide ion. So its aqueous solution is basic in nature. Move to the next chemical property. That is the formation of complexes. The second chemical property, formation of complexes. When aqueous solution of ammonia, that is ammonium hydroxide, treated with aqueous solution of copper sulfate, aqueous solution of silver nitrate, aqueous solution of silver chloride, resulting in the formation of complexes. Mark that. CuSO4 plus ammonium hydroxide, resulting in the formation of tetraamine copper 2 sulfate, tetraamine copper 2 sulfate. Similarly, silver chloride treated with ammonium hydroxide, resulting in the formation of diamine silver 1 chloride. It is diamine silver 1 chloride plus H2. These are known as some examples of formation of complexes. Next chemical property, that is formation of insoluble salt, insoluble compound, or formation of precipitate. Next one, next chemical property, formation of precipitate. That is the soluble salt of aluminium, iron, chromium, when treated with aqueous solution of ammonia, resulting in the formation of insoluble precipitate. Mark the equation. Aluminium chloride combines with ammonium hydroxide, resulting in the formation of aluminium hydroxide plus ammonium chloride. It is white precipitate. Ferric chloride plus ammonium hydroxide, resulting in the formation of ferric hydroxide plus ammonium chloride. It is brown precipitate. Aluminum chloride form aluminum hydroxide, ferric chloride form ferric hydroxide, chromium chloride plus ammonium hydroxide, resulting in the formation of chromium hydroxide plus ammonium chloride. That is green precipitate. These are some examples of precipitation reaction. Move to next chemical property, that is action with chlorine. Very, very important one. Two type of question is there, 2 mark question. What happens when excess ammonia reacts with chlorine? What happens when insufficient amount of ammonia reacts with chlorine? Mark that. Next chemical property. Next chemical property, action with chlorine. 8 NH3 plus 3 Cl2 give rise to N2 plus NH4 Cl. Here ammonia is known as excess. Next one, NH3 plus 3 Cl2. Here chlorine is known as excess. Give rise to NCl3 plus 3HCl. It is known as nitrogen trichloride, used as an explosive. Mark that, very very important one. When excess of ammonia reacts with chlorine, resulting in the formation of ammonium chloride with the evolution of nitrogen. On the other hand, when insufficient amount of ammonia reacts with chlorine or excess chlorine reacts with ammonia, resulting in the formation of nitrogen trichloride, which is used as an explosive. Move to next chemical property, action with carbon dioxide. Next chemical property, that is action with carbon dioxide. When ammonia reacts with carbon dioxide, resulting in the formation of urea. Mark the equation. NH3 combined CO2, resulting in the formation of NH2CO, NH2 plus H2O. It is known as urea. When ammonia combines with carbon dioxide, resulting in the formation of urea. These are some chemical properties of ammonia. Next, switch over to uses of ammonia. Uses. So many uses are there. That is liquid ammonia used as a good refrigerant. Mark that. Liquid ammonia is used as good refrigerant. It is used in the manufacture of urea. Next, it is used in the manufacture of nitric oxide. These are some uses of ammonia. Next, switch over to the oxoacid of nitrogen. Nitrogen forms so many oxoacid, that is, some common are N2O, NO, NO2. These are some oxides of nitrogen. Example, N2O, NO, NO2, N2O3, N2O4, N2O5. These are some oxides. Nitrous oxide, nitric oxide, nitrogen dioxide, dinitrogen trioxide, dinitrogen tetroxide, and dinitrogen pentoxide. These are some oxides. Last, switch over to the allotropic form of phosphorus. Next, allotropic. Last, that is allotropic forms of phosphorus. Generally, there are 5 allotropic forms of phosphorus: red phosphorus, white phosphorus, black phosphorus, that is red phosphorus, black phosphorus, white phosphorus, scarlet phosphorus, brown phosphorus. These are some allotropic form of phosphorus. What do you mean by allotropic form? That is, various form of the one element, having similar chemical properties but differing in physical character, physical behavior are known as allotropic form, and the phenomenon is known as allotropy. I repeat again. Various form of the one element having similar chemical property but differ in physical property are known as allotropic form, and the phenomenon is known as allotropy. These are some common allotropic form of phosphorus. It is all about the chapter group of 15 elements or nitrogen family.